There's a fruit most Americans have never tasted, never eaten, and never used for anything. They walk past it every autumn on roadsides and beneath fence lines across 30 states. They kick it off sidewalks. They throw it into ditches. Midwestern farmers once collected every one they could find and distributed them carefully through their homes before winter. They never explained why to their grandchildren, and the grandchildren never asked. The fruit is the Osage orange. Also called hedge apple, horse apple, monkey ball, and spider ball, depending on which part of the country you're standing in when you ask. It is roughly the size of a grapefruit, covered in a wrinkled, bumpy surface that looks nothing like any food a person would willingly approach. Bright green in autumn, turning yellow as it ripens and falls from the tree. It smells unmistakably of citrus, a sharp, clean, almost resinous citrus smell that carries several feet from the fruit. And that is, for most people who encounter it, the most interesting thing about it. The second most interesting thing is what Midwestern farm families did with it for generations. Two things explain why this tradition disappeared from American homes so completely in the space of a single generation. One involves the chemistry of what is actually inside the Osage orange fruit, and what researchers found when they finally looked. The other involves the same story that has erased dozens of practical folk traditions in the 20th century. The arrival of a manufactured, purchasable product that solved the same problem on a schedule, convenient for the people selling it. By the end of this video, you will understand exactly what farmers believed this fruit did, what the research actually found when scientists examined those beliefs, and why a tree that drops free fruit across 30 American states every autumn has become so thoroughly invisible. To the generation that inherited the land it grows on, the place to start is not with the fruit, it is with the tree. Maclura pomifera, the Osage orange, is one of the most distinctly American trees in existence. It is native to a small region of what is now Arkansas, Oklahoma, and Texas. The Osage Nation's historic territory, which is where the tree got half its common name. The wood is extraordinarily dense, rot-resistant, and hard enough that a single fence post driven into the ground in the 19th century can still be found standing in the 21st, outlasting every other native timber used for the same purpose. Native American tribes prized it above almost every other wood for making bows, valuing it so highly that trade in Osage orange bows extended hundreds of miles beyond the tree's native range, into regions where it did not naturally grow. Early European settlers observed this and called it bois d'arc, wood of the bough, a name that persists in parts of the South today and that gives the town of Bowie, Texas, part of its linguistic heritage. When barbed wire was still decades in the future, Osage orange trees were planted in rows across the Midwestern prairies as living fences, hedges so dense and thorny that cattle refused to push through them and predators could not penetrate them. The United States Patent Office actively promoted Osage orange hedging in agricultural publications in the 1840s and 1850s, recommending it as the solution to the fencing problem that was limiting agricultural development on the treeless plains. By the mid-19th century, millions of Osage orange trees had been planted across the Great Plains, creating the hedgerows that still crosshatch the landscape of Kansas, Iowa, Missouri, and Illinois in aerial photographs today. Then, barbed wire arrived in 1874. Within 2 decades, it had almost completely replaced the living hedge. The trees that had been planted so deliberately were no longer being planted, no longer valued for the purpose they had been introduced for. But they were still there, still growing, still spreading along fence lines and roadsides, still dropping their enormous, strange-smelling fruit every autumn to be kicked into ditches by people who had no idea what the tree had once been planted to do. Every one of those trees drops fruit every autumn, enormous quantities of it. A single mature female Osage orange tree can drop dozens of fruits in a season, each one the size of a softball, each one releasing that sharp citrus smell as it decomposes slowly on the ground beneath the tree. Stay with me, because what farmers believed about that smell is the part that opens the actual file on this fruit. Somewhere in the agricultural tradition of the Midwestern farm, a belief took hold and spread across generations. The belief was that Osage orange fruit placed in a cellar, a barn, or around the baseboards of a farmhouse kept insects and spiders out through the winter months. It was not the kind of belief that came with documentation or explanation. It was the kind that gets passed from a grandmother to a daughter while collecting the fallen fruit from beneath a hedgerow one October morning. Hands cold, breath visible in the autumn air, the sharp citrus smell rising from every fruit they dropped into the basket. You collect these, you put them in the corners of the root cellar, in the barn, along the baseboards of the kitchen. They keep the bugs away through winter. No explanation of why, no theory of what compound was responsible or how it worked. Just the observation, repeated over enough generations to become unquestioned practical knowledge, that the farms where this was done seemed less troubled by insects and spiders through the cold months than farms where it was not. The tradition spread through the Midwest the way all agricultural traditions spread, through neighbors, through family, through the dense networks of practical knowledge, sharing that rural communities maintained before there were extension offices, or agricultural colleges, or YouTube channels to carry information. By the late 19th and early 20th century, the practice of collecting Osage orange fruit in autumn and distributing it through home and farm was widespread enough across the Midwest that it had earned its way into multiple common names for the fruit itself: spiderball, spider apple. The name encoded the function, the same way the name inkberry once encoded exactly what pokeweed was useful for. For generations, it worked, or appeared to work. What researchers found when they finally examined this tradition formally is more interesting than either a simple confirmation or a simple debunking. Scientists at Iowa State University extracted chemical compounds from Osage orange fruit and tested their effect on insects in laboratory conditions. They found that the fruit contains a compound called tetrahydroxystilbene and another called elamol, and that both of these compounds, when concentrated and isolated, repel insects measurably in enclosed laboratory spaces. A later study found that elamol specifically shows measurable promise as a mosquito repellent, with effects in laboratory testing that attracted enough scientific interest to generate ongoing research into its potential as a natural insect repellent compound. Researchers at the University of Minnesota Extension also identified that the essential oil of Osage orange is a repellent to German cockroaches under controlled conditions. The research across multiple institutions is consistent in finding that the chemistry inside this fruit is not imaginary. The compounds are real. Their biological activity against insects is real and measurable. The question that remains open is the one about whole fruit effectiveness in open domestic spaces. A question that the folk tradition never asked and that science has not yet definitively answered in either direction. Here is where it gets complicated in a way that every honest account of this plant has to acknowledge. The natural concentration of these compounds in a whole, intact Osage orange fruit is too low to function as a reliable insect repellent in the open spaces of a farmhouse or a modern home. The chemistry that repels insects in a laboratory at concentrated levels is diluted significantly in the fruit itself, and diluted further by the air volume of any room larger than a very small enclosed space. The fruit produces and releases these compounds, but in quantities that most entomologists consider insufficient to drive insects from a building. What this means is that the tradition was real. The chemistry behind it is real. The practical effectiveness of placing whole fruits around a full-sized home is genuinely uncertain and has not been demonstrated under controlled conditions. And the farmers who practiced this tradition were not foolish. They were working with an observation that appeared consistent across generations of use, and that has, decades later, been found to contain real chemical mechanisms that science is still studying for potential applications. The Iowa State researchers noted something else. The concentrated extract of Osage orange, not the whole fruit, but the extracted and concentrated compound, shows genuine laboratory effectiveness against German cockroaches and other insects. The fruit is not useless. The chemistry is not fictional. What is currently fictional is the marketing language that has accumulated around the whole unprocessed fruit in the folk tradition, and in the modern natural products market that has discovered, and is now selling what it calls spider balls, to people who grew up hearing about what their grandmothers did. Here is where the commercial story becomes worth examining. Farmers markets across the Midwest sell Osage orange fruit every autumn, positioned as natural spider and insect repellents, priced at $1 or $2 per fruit. This is the same fruit that falls free from trees along roadsides and fence lines across 30 American states. The same fruit that Midwestern farmers collected without paying anyone. The tradition that their grandparents practiced freely has been commodified, repackaged, and sold back to the generation that inherited the land the trees grow on. The chemical compounds inside the fruit that the Iowa State researchers identified are legitimate targets for commercial development as insect repellents. Elamol is actively being studied. Tetrahydroxystilbene has measurable biological activity. The research is ongoing, and the potential for refined, concentrated products derived from Osage orange fruit chemistry is real. That research happens in laboratories, not in October afternoons beneath a hedgerow. And the products that emerge from it will be sold in bottles by companies that hold patents on the extraction and formulation process. The tree will keep dropping its fruit for free. The fruit will keep containing the compounds the research found. And most of the people who walk past the fallen fruit every autumn will continue to kick it into the ditch without connecting what is inside it to any of this. Now here is what the Osage orange tree actually offers anyone willing to look at it with the full attention that Midwestern farmers once gave it. And this part requires no uncertain folk chemistry and no laboratory debate. The wood is extraordinary in ways that have nothing to do with the fruit. A fence post made from Osage orange heartwood outlasts treated pine posts by decades. Because the wood is naturally resistant to rot, insects, and moisture in a way that almost no other native North American timber matches. Old-growth Osage orange fence posts placed in the ground in the 1870s have been found still structurally sound in the 1970s, 100 years in the ground. A treated pine post typically lasts 20 to 30 years in most conditions before it begins to fail at the base. Osage orange heartwood, placed in the same ground under the same conditions, is still standing when the replacement posts are already being installed on the neighboring farm. The reason is the chemical composition of the heartwood itself. The same broad category of compounds, stilbens and related polyphenols, that researchers found in the fruit are present in high concentration in the heartwood, where they function as natural preservatives that resist the fungal and insect attack that causes other wood to rot. This is well established and not debated. The durability of Osage orange as a fencing timber is documented in historical agricultural records, and confirmed by anyone who has ever tried to split a piece of it with a maul and walked away bruised and humbled. The flowers are exceptional for bees. Osage orange is one of the highest value native trees for bee forage in its range, producing nectar that beekeepers have valued for as long as there have been managed bee colonies in the Midwest. Old beekeeping texts specifically mention Osage orange bloom as a significant honey source, and the floral period, which arrives in late spring when other nectar sources may be scarce, makes it valuable in the seasonal nutrition calendar of managed and wild bee populations alike. The wildlife value is similarly underappreciated. The fruit that everyone kicks into the ditch is, for squirrels, a significant and nutritionally rich food source. Eastern fox squirrels in particular invest considerable effort in accessing the seeds packed inside the dense, tough fruit, and they cache them for winter consumption. A mature Osage orange tree producing dozens of fruits annually is providing substantial winter wildlife support in any landscape where it grows. The combined offering of rot-resistant timber, exceptional bee forage, wildlife support, and the distinctive thorny hedgerow structure that the tree naturally develops makes Osage orange one of the most genuinely useful trees in its native range, regardless of whether any of the insect-repelling folk tradition is ever conclusively validated. And yet most Americans who live within its range have never planted one on purpose, never thought about what the fruit they kick aside in autumn is connected to, and never asked why the hedgerows full of these trees were planted by previous generations of farmers who had no interest in planting anything that did not serve a clear practical function. And the compounds inside that fruit are continuing to attract research attention. The Elemol studies are ongoing. The tetrahydroxystilbene research has not been concluded. The Iowa State work was preliminary, not final. The folk tradition that Midwestern farm families practiced for generations was based on real chemistry, even if the practical effectiveness of the whole fruit application was never formally established. Future refined applications of what is inside this fruit remain genuinely open questions that science has not fully answered. Here's what is not an open question. The tree grows wild across 30 states and drops its fruit for free every autumn. The fruit contains chemistry, Elemol and tetrahydroxystilbene, that repels insects at concentrated levels in laboratory conditions. The tradition of using it in homes ran across multiple generations of practical and sentimental farm families, who kept doing it because it appeared to produce results consistent enough to be worth the small labor of collection. The wood from the same tree is one of the most durable natural fencing materials in North America, with documented longevity that exceeds treated pine by decades. The flowers feed bees at a time of the season when nectar is often scarce. The fruit feeds squirrels through winter. The thorny thickets that the tree naturally forms create wildlife habitat that an open, managed landscape cannot replicate. And the generation that stopped collecting the fruit stopped, not because the tradition was proven wrong in any definitive way, but because a spray can show up on a hardware store shelf, and the grandmother who knew why you collected the fruit each October was no longer there to explain the connection between the hedgerow and the cellar and the winter quiet of a farmhouse that was somehow never overrun. The Osage orange does not need anyone to validate the folk tradition to be worth paying attention to. The tradition adds one more layer of interest to a tree that is already remarkable on its own terms. The chemistry that underlies that tradition is real enough to have attracted university research, and to be generating ongoing scientific interest decades after the Iowa State team first extracted the compounds and found that concentrated, they worked. What the tradition needed, and what it never had, was someone to figure out how to extract the active compounds at effective concentrations and sell them in a bottle. The tree itself never needed that. It was already dropping the fruit every autumn, already growing the timber that outlasts every alternative, already feeding the bees every spring, already providing the habitat that a cleared, managed landscape cannot. The grandmothers who collected it understood this in the way that you understand something you have been doing your whole life without needing to explain it. The fruit smells like something useful. The cellar where it was placed stayed quieter through winter than cellars elsewhere. The knowledge was experiential before it was chemical, practical before it was scientific. and passed down before anyone thought to write it into a study or file a patent on the extract. They never explained why to their grandchildren, and the grandchildren never asked. But the fruit is still falling from the same hedgerow trees that were planted generations ago for reasons most people living near them today have also never thought to ask about. Walk past one this autumn a little more slowly than you usually do. If you found this genuinely useful, watch the next video and do not forget to subscribe. See you in the next one.